Man's earliest days, he has relied on swift reflex actions to stay alive when danger threatens. Our military leaders took this as a lesson in planning the defense of our continent. They say that today, when a surprise attack would allow us only a few minutes' warning, our defense system must be able to detect the enemy and react as quickly as a human being. To that end, the United States and Canada decided to give this continent eyes, brains, and muscles that could react as swiftly as yours and mine, and with even greater efficiency. It seemed at the time an impossible goal. But let me tell you what we actually have today. To detect jet bombers long before they reach our shores, rings of radar eyes have been built across the northern part of the continent. We also have radar looking out to sea, in land-based installations along our coasts, in towers planted offshore, in picket ships, airplanes and blimps. Many of these radar posts serve as eyes for the SAGE air defense system, which can automatically identify, track, and direct the destruction of enemy planes. If an enemy attacked, the alert would flash to the brains of our whole defense system, to Norad, the North American Air Defense Command headquarters in Colorado Springs. At the same time, civil defense agencies would warn the people in our cities. Then our muscles, in the form of jet interceptors and surface-to-air missiles, would get into action, while our long-range bombers and missiles are on their way to destroy the enemy's bases. All of these eyes, brains, and muscles give us strength. But we need one more thing, perhaps the most vital element of all, a nerve system over which communications can be flashed in an instant's time, so that our defense system can spring into action in one controlled thrust. Our military leaders knew this continent already had such a nerve system, designed for peacetime use, but ready to serve the cause of defense. Much of this nerve system is hidden underground, but there are places where you can see it clearly against the sky. I'm speaking of the nation's telephone network, whose microwave towers and cables lace the farthest village and town into a vast web of communications. This is the system that makes our defense go. It's the same network you use when you pick up your telephone to call someone in a distant city. And it's the same network the nation uses to carry on its daily business. Almost everywhere you look, you can see the vision of Alexander Graham Bell in millions of telephones carrying the voices of a nation, and in the facilities and services which bring you news, television programs, and the pictures you see in your newspapers. And telephone networks today don't stop at the waterline. We have underwater cables that span the oceans. They're important to overseas communications because they're not affected by magnetic storms and other atmospheric disturbances. These cables provide instant all-weather communications with Hawaii, Alaska, Puerto Rico, and Cuba, Great Britain, continental Europe, and with our overseas military bases. Today's telephone network far exceeds Mr. Bell's grandest dream, and every last inch of it can be linked together to serve the home, business, or continental defense. The very size and diversity of this network help to make it strong. But telephone companies have taken many other steps to ensure reliable communications during times of disaster. All across the country, trained people stand ready with emergency supplies and equipment. If electric power to telephone buildings should be knocked out, batteries and generators are ready to take over. And more underground cables are being installed across the country, providing additional alternate circuits that can withstand damage from storms or falling bombs. And to make this system even more dependable, telephone men have built great networks of communications that bypass critical military targets. Express routes reaching across the nation avoid large cities entirely. Other main routes connect with the express routes and go around the big cities as well as between them. If any of these cities were destroyed, communications could bypass them and continue to give nationwide service. Today, from stations clinging to wild and remote cliffs, radar antennas probe deep into the skies above the top of the world. Vigilant sentinels that never close their eyes. Providing reliable communications in this wild North Country was quite a problem. In the land where many people had looked to the dog sled and the bush pilot for their only contact with civilization, telephone men used a new kind of transmission to construct not only the dew line, but the Alaskan communication system, known as White Alice. And the silent land became electronically alive. Huge antennas designed by Bell scientists beam powerful microwaves over the horizon to be received and relayed by other antennas. Today, White Alice ties together our Alaskan military outposts and connects with the dew line to complete our communications network across the top of the continent. If enemy planes should try to fly in across our northern borders, the dew line antennas would spot them, and men on duty would observe their tracks on radar scopes. The information would flash to Norad. To me, Norad symbolizes the cooperation between the armed services of two countries. The United States Air Force, Army and Navy, and the Royal Canadian Air Force jointly operate this key headquarters. Norad is a busy place. Information flows in by wire and radio from many different radar detection posts. In addition to radar stations at strategic points along our coastlines, many others far out at sea give us extra minutes of warning time if attack should come from across the oceans.
North American Air Defense Headquarters, protecting both America and Canada, direct communication exists with SHAPE, Allied headquarters near Paris, and with its subordinate commands in Europe. Within SHAPE itself is a command post called SHOC, SHAPE Operations Center, which is in constant touch with all the forces in the field that help defend Western Europe. Maintaining communications is a difficult job with standard equipment. NATO needed something better than the usual radio relay systems, which are subject to interference and may be overheard in Eastern Europe. Today, when a staff officer issues an instruction or receives information, he uses forward scatter, a brand new communication system that keeps the headquarters in touch with Izmir in distant Turkey, or from the same central station near Paris, brings Naples at the end of a telephone, or extends down the entire Norwegian coast to Oslo. The result of years of applied research, the principle of forward scatter is simple enough. Standard relay systems use a chain of many small stations, each beamed directly one to the next. Around the Earth exist layers of particles, the ionosphere and the troposphere, known to reflect radio signals. Messages can be bounced off these layers to a station many hundreds of miles away. The costly and easily jammed intervening stations are eliminated. In Norway, 4 stations join the country from end to end, built on mountaintops and angled at the next station in the line. They are linked in Holland by a different kind of transmitter, relaying messages to and from SHAPE and SHOC. This revolutionary system assures that through its own headquarters, any unit of NATO in Europe is linked to supreme headquarters of the Allied powers. This Norwegian patrol ship is a typical member of the NATO team. Wherever it goes, it is linked with the forces of 15 nations by modern communications networks, which are devised, built and operated for defense by the scientists and technicians of NATO.